Welcome to practice test 5, mathletes. So here we go. Let's jump right in. So number one, so we're using implicit differentiation here. Please use, or for each problem, use implicit differentiation to find y prime in terms of x and y, right? So what we'll do is we'll differentiate this. Remember, y prime, dy dx are kind of synonymous, right? If I don't state otherwise, y prime is always going to be dy dx, okay? Unless I say unless it's in terms of another variable, and I'll tell you like dy dt or dy something else, okay? So anyway, and on this test it'll be dy dx, okay? So we're going to ddx everything, right? Remember, this is before related rates when we ddx things instead of ddt. And so what's going to happen is anything with the x, I'm just going to derive as normal. So the derivative of 8x to the 7th is going to be 56 x to the 6th, right? So I just multiply by the exponent and then take away 1. And then here we have a product rule situation, right? So we have an f function and then we have a g function. So we're going to do f prime g. So that's going to be the derivative of f. And so that's going to be 56 x to the 7th. And then we just bring down the g term, which is y cubed, right? Plus, now I'm going to do f times g prime, right? And so I'm going to multiply this 3 in the front. I'm just going to multiply it by the 7 since the 7 is still there. So it'll be 21 x to the 8th. So the x term stays the same, but then we take away 1 from the exponent, right? So another way to write that is you can just write the 7x to the 8th and then bring down the 3x squared, or excuse me, 3y squared, right? Which is the derivative of y cubed is 3y squared, right? And then we just multiply these. And so that's how we, excuse me, get that 21. All right, now, one thing that I haven't put in here yet is y prime, right? So when I take the derivative of the y part of it, in this case the g function, I'm going to tag on a y prime, okay? And so don't forget to do that. All right, sorry for the background noise as well. I usually do these late at night, but this one doing while kiddos are awake, so got some stirring in the house. All right, anyway, so this whole thing is the derivative of this, right? Because it's the product rule, f prime g plus fg prime. All right, and then now we're on to this one. So the derivative of 8y squared is just 16y to the first, right? But then we have to tag on a y prime, right? And remember, those are dy dx's, right? We don't have to tag on x primes to the x functions that we take derivatives of, because x prime is dx, which is actually just 1, right? So it's kind of like an invisible or implied 1 there. All right, so anyway, now that we're here, now we want to isolate y prime, right? We want to get the y prime terms by themselves. So we have a y prime here and a y prime here. So I want to move everything else to the other side. So I'm going to subtract 56 x to the 7th y cubed to both sides. All right, and then those will cancel out. And so on the left side, we'll end up with 56 x to the 6th minus 56 x to the 7th y cubed, okay? And so notice how I have this left over on this side. So what I'm going to do is, right now I'm going to factor out a y prime, okay? So this is kind of some mathlete stuff right here, right? So I'm going to factor out a y prime, and I'm going to put all the leftovers back inside. So this is leftover 21 x to the 8th y squared, and then 16y, okay, plus 16y. All right, so we just factor out the greatest common factor, or not necessarily the greatest common factor, but the common factor of y prime. That way now we can isolate it by dividing by this whole value, right? So we can divide by 21 x to the 8th y squared plus 16y. We can do that on both sides. Okay, and so those will cancel out. And now we have y prime all by itself. So y prime, aka dy dx, equals 5x to the 6th minus 56 x to the 7th y cubed all over 21 x to the 8th y squared plus 16y. Okay, and remember that as far as simplifying, if it involves factoring, you don't have to simplify. So like you don't have to, like in this case, factor out a x term or a y term and reduce that way. So this is good. But if it's like a monomial over a monomial or something like this, a monomial multiplied by a monomial, make sure that you simplify that, right? Those are things that, you know, are reasonable to simplify, and so we'll do that to that extent, okay? So this is the answer here. I also put an answer key on the attach it to the Canvas post, and so you have an answer key that has answers on it for practice test 5 as well. Okay, so you can check that out and compare your answers and things like that, and hopefully I'm matching up. Note that their answers may be more simplified than the ones that I do, just because that's not our, you know, that's not our focus, and so there may be some differences in the answer key, and that may just be because yeah, we didn't simplify as much as they did. All right, but let me know if you find something where you think it's wrong, and anytime there's a video like that, yeah, let me know and we'll get it resolved. So all right, move on to number 2.